Hey pre-calculus students, this is our 7th lesson in our first module. I'm going to go kind of quickly today. We basically had two big takeaways. Students will be able to find the multiplicative inverse of a complex number, and they'll also be able to find the conjugate of a complex number. So I'm going to keep this video kind of brief. We may cut out some of the stuff just in the interest of time. But for a second, let's look at our do now. It says respond to opening exercise on S23 of your binder. So go down to that page. Basically these first 5 questions, which is just doing some arithmetic, which we've done before. So go ahead and do these out on your own. I'll check when I check your binders. I'll check to make sure that you tried these out. The one I want us to focus on though for today is question E, because we're going to be using some ideas from it throughout the lesson. So this is a multiplication problem. If I have 2 complex numbers, I need to make sure I distribute each to each. So there's 4 multiplications here. -4 times -4 is 16. -4 positive 5i is -20i. -5i and -4 is positive 20i. And then -25i times I is I squared. So that's what we get initially. Let's take a couple seconds and simplify. I see a positive and a -20. They cancel. 16 minus 25, and then I squared is equal to -1. That's one of our very, very important identities. I plug it in there. 16 minus -1 times 25, so that's minus a -25, so that's plus 25, which gives me 41. So I picked this example because I wanted us to see 2 things that came out of this. One, we multiplied 2 complex numbers and we got out just a real number down here. So that's a really important outcome. We're going to be using this as we start to think about multiplicative inverses today and then division in the next lesson. Let's see what's special about these 2 numbers. Notice these 2 numbers are almost the same. The real parts are the same. They're both -4, but our complex parts, our imaginary parts rather, have the opposite sign. So these 2 numbers, these 2 complex numbers are called conjugates. What's special about them is that they have opposite imaginary parts. And then something that's special what happens when we multiply conjugates is that we get just a real part out at the end. So we're going to use that today as we start to think about multiplicative inverses and then division tomorrow. Great. So again, make sure you try out each of these arithmetics. They shouldn't take very long. Just a quick refresher on how to add, how to multiply, subtract, multiply again. All right. So let's see this pattern start to extend. So our goal is to find a multiplicative inverse. So on your note sheet for today, our job, let's just focus on example 4. A multiplicative inverse is something that when we multiply it by a number, it gives us 1 in the end. So we're saying, is there a number that we could multiply by 3 plus 4i that would just give us 1? So in class, as we stepped through this, we basically found, well, if we just flip the number over to be something like this, basically turn it into a divide by that number, 1 over 3 plus 4i, those should cancel and equal 1. Let's see how. When we multiply fractions, I like to turn them both into fractions, multiply across, we get 3 plus 4i over 3 plus 4i. When we have something on top of fraction and that same thing on the bottom, that is just equal to 1. So this right here is an example of a complex number, a multiplicative inverse of 3 plus 4i. But it's not in a form we like. Mathematicians don't like having this I on the bottom, the imaginary number on the bottom. We really like our numbers in A plus BI form so that we can plot them, we can find their modulus very easily. We know a lot of tools that rely on us having our number in that form. So that's what we did in example 5. And in class, we went through a pretty long proof showing how we could come up with this number algebraically. I'm going to save us those steps, though, and just cut to what we need to know to master this for today. So overall, we're looking for a number in the form a plus bi like this, that when multiplied by a complex number gets us 1. That's our goal for today. So going back to the back side of that note sheet, we started to check this out. We're like, well, we noticed in the activator that when we multiply by conjugates, we get a real number. So that gets us pretty close. So here I've set out 3 pairs of conjugates. These are all conjugates. So let's see if multiplying these gets us to where we need to be. I'm going to pick this middle example. You should do all 3. 5 times 5 is 25. 5 times plus 3i is plus 15i, minus 15i, and minus 9i squared. And I know I'm moving quickly, but feel free to pause this video and double check things as you go. Those imaginary terms, they are opposite, so they cancel, and we're just left with 25 minus 9 times negative 1. That's just 25 plus 9, which is 34. So we wanted to test to see, like, well, are conjugates multiplicative inverses? They're not quite multiplicative inverses because they gave us not 1, they gave us 34. We should have gotten 1 if they were multiplicative inverses. But it got us close because it got rid of all the imaginary pieces. We just had a real number. So all we have to do with this number now to get to a 1 is divide it by itself, and now we'd had 1. So basically, by looking at this pattern, we saw, oh, multiplying by the conjugate almost is the multiplicative inverse. It's not quite there. We also need to divide by something else. What we noticed when we did all 3 of these out is that we needed to divide. What would you need to do to each result to make it equal 1? We would need to divide by a squared plus b squared. So we had this number here, a plus bi, 5 minus 3i. A plus b squared would be 5 squared plus negative 3 squared, which is just 25 plus 9, which is 34. So we notice the conjugate gets us almost there, it gets us a real number. We just have to divide by the sum of the squares, a and b, the sum of a squared plus b squared, and then we get back to our multiplicative inverse. So in general, what do we need to find the multiplicative inverse? First, we need to find the conjugate. Find the conjugate, then divide by a squared. That's sloppy. A squared plus b squared. All right, so in general, if we have some number, a plus bi, that's our original number, to find the multiplicative inverse, that is something that multiplies to make 1, we need to get the conjugate. I'm going to write it on top. A minus bi, the conjugate just changes the imaginary part to a negative, divided by a squared plus b squared. And I'm just going to make a note. Altogether, this is the multiplicative inverse. And just this piece on top, just that, good color here, just this a minus bi, that's the conjugate of the number a plus bi, just taking the opposite. So we need that and the a squared plus b squared to get our multiplicative inverses. So we saw an example of this. Basically what you need to do on your ticket is find the multiplicative inverse, verify it, and also find the conjugate. So let's practice finding this inverse. There's our number, a plus bi. Remember, we need 2 things. We need our conjugate, and we need a squared plus b squared. We divide them. Here our conjugate is just taking the opposite of the imaginary part. So that would be 5 minus 3i instead of 5 plus 3i. So that's our conjugate. And then we need to divide by a squared plus b squared. Well, divide by a squared plus b squared. Well, a here is 5. B is 3. Notice it's not 3i, it's just the coefficient on I, just 3. So that's going to be 5 squared plus 3 squared. So altogether that would give us 5 minus 3i all over 25 plus 9, or 5 minus 3i all over 34. So right there is a quick example of finding our multiplicative inverse. We needed the conjugate, just changing the sign to an opposite, and we needed to find the sum of the squares, a squared plus b squared. All right, so what you should do right now is look at these two problems and try them out on your own. I'm not going to stop the video and restart it. I'm just going to have you pause it. You should try these two numbers out. Remember, we need the conjugate for both, and then you also need to put it over a squared plus b squared to get the inverse. So go ahead and pause the video, try these two out, and then we're going to focus on this second one here, number 7. So pause the video, try out 3 and 4, and then I'm going to show us the answer to number 4, and then come in and take your exit ticket. All right, so hopefully you paused and tried this out. I'm going to start filling in. Our conjugate is 7 plus 2i instead of 7 minus 2i. All we did was change the sign of the imaginary part. A squared plus b squared is going to be 7 squared plus 2 squared, which is 49 plus 4, which is 53. So our inverse, the steps in this problem were to state the conjugate. So there's our conjugate, check, and then use the general formula, that's back from our notes, to find the multiplicative inverse. So our inverse will be the conjugate, 7 plus 2i, inverse equals 7 plus 2i divided by 53. So that would be that one. Another thing you're going to be asked to do on the exit ticket is verify that this is the inverse. So in other words, make sure that our original number, 7 minus 2i, the original number, times our inverse, 7 plus 2i, all over 53, show that those two multiplied is in fact equal to 1. So on your exit ticket, you should be able to set this up. This should be true. Now do out the work to make sure. I like to, again, treat them both as fractions. This would be our verify step. 7 times 7 is 49. 7 times positive 2i is 14i, minus 14i, and then minus 4i squared, all over 53. Again, we're checking, is this equal to 1? Is it equal to 1? 49, these two cancel. 49 minus 4 times negative 1 over 53. That is, sure enough, 53 over 53, which is 1. So this work is something you'd have to show out on your exit ticket. 1, can you find a conjugate? We can do that. It's really easy. 2, can you find the inverse? So combining the conjugate and dividing it by our total, a squared plus b squared. And then can you check that it does, in fact, take you back to 1 when you multiply? That's what we need to know for today. I know this was a shorter video than most, and it's not as detailed as I would like, but I will make sure in the future they are giving you everything you need. All right, next we have lesson 8. We're going to use these ideas of conjugate and multiplication and inverses to come up with how to divide. So that's what we're looking at next. Come into class, try out your exit ticket, and you will be all set on this lesson.